Chapter 10, Lesson 6 is a little more involved. It's a little more work than the rest. We have to use several pieces of information in our previous knowledge. Area of the right triangle shown below is 26.46 inches squared. So I know the area of this is 26.46 inches squared. What is the perimeter of the right triangle? So I'm going to start with the area information. Area of a triangle is 1/2 base times height. The base and the height make the right angle. I'm going to call this the height, and I'm going to call this the base. Here's the right angle. Those two sides make it. I know the area is 26.46, and I don't know what B is, but I do know H is 6.3. So the first thing I do is I take these two, 1/2 and 6.3, and I put them together by multiplying those two things. So 0.5 times 6.3 is 3.15 times B. But I want B by itself, so I divide both sides by 3.15. And what this is going to give me is the length of the base. So 26.46 divided by 3.15, and I get 8.4. So B is 8.4. Now in order to find the perimeter, I need to know all the sides. That's the distance around the outside. So I still need to know this long side here, which is C. So I need to use the Pythagorean theorem now to find the long side. 6.3 squared plus 8.4 squared equals C squared. 6.3 squared is 39.69. 8.4 squared is 70.56. That's C squared. So then I add these two together. 110.25 equals C squared. I take the square root of both sides. And I get C is 10.5 inches. So I'm almost there. And now what I do to get the perimeter is I add up all the sides. So P equals side 1 plus side 2 plus side 3. So 6.3 plus 8.4 plus 10.5. And I get 25.2 inches. So we had to do quite a bit of work in order to find that answer. It's all things we've learned already. It's just putting a lot of things together. Number 2, the diagram below is a representation of a soccer goal. Determine the length of the bar C that would be needed to provide structure to the goal. Round your answer to the 10th place. So each of these triangles is the same. This is A and this is B. So A squared plus B squared equals C squared. 8 squared plus 3 squared equals C squared. 64 plus 9 equals C squared. I add those together. 73 equals C squared, and then I take the square root of both sides. And it's 8.5 feet. So this is another use of Pythagorean theorem. Then it wants to know how much netting in square feet is needed to cover the entire goal. So we're trying to find now the area of these pieces here. So this piece right here, which is the same over here, is a triangle, and the area of a triangle is 1/2 base times height. So 1/2, 8 times 3, that's 12, but we have 2 of those pieces. So 12 times 2, that's 24 feet squared. That's part of it. That's for the 2 outside triangles. And then the rectangle in the middle, that's length times width, is 10 feet across times 8.5, the answer we found, which is 85 feet squared. And now I add these two together, 24 and 85 is 109 feet squared total netting. So again, another question where we've learned how to do the pieces, now we just need to put it together. Number 3, the typical ratio of length to width that is used to produce televisions is 4 to 3. So the length would be 4, the width is 3. That's a ratio. When the size of a TV is stated, it is actually referring to the diagonal. When they measure TVs and they tell you you're buying a 19-inch TV, it really is the distance across the diagonal. That's 19 inches, not the length. So if I have a TV that is 5 times the typical ratio, what size is it? Usually it's 4 to 3. So this is 3. So generally, my TV, if this was 3 inches by 4 inches, this is A and B, or we know the most common triangle is a 3, 4, 5. So when we plug in 3 squared plus 4 squared equals C squared, 9 plus 16 equals C squared, that's 25 equals C squared, and when I square root this, we find out it's 5. So the ratio is 3, 4, 5, but it says in this question it's 5 times the typical ratio. So we're on the diagonal now. If this is 5, we have a TV 5 times the original ratio. So our TV would be 25, whatever unit is big. A 42-inch TV was just given to your school. What are the length and width of the TV? So B is a little different. We know that the ratio of the sides are 3 to 4. So here's my, I'm going to redraw it so I have to keep flipping up there. We know that this is 42. And this is 3 to 4, the ratio, but I don't know how big it is. So we call it x. So we're still going to use the Pythagorean theorem, but it's a little different now. It's 3x squared plus 4x squared equals 42 squared. So I get 9x squared plus 16x squared equals 1,764. That's 42 squared. Now I solve this equation by combining these two together because they're like terms. And that's like a 9x plus 16x, which is 25x squared equals 1764. I divide by 25. You get x squared equals 70.56. We take the square root of both sides again. So our part of our answer is x equals 8.4, but that's just our ratio. Now I know that it's 3 times whatever x is for the width. So 3x, which is the width, is going to be 25.2 inches. And the length is 4 times x, so 4 times 8.4 is 33.6 inches. So this would be my dimensions. The stand for the TV is 30 inches in length. Will the TV fit in the stand? My TV is 33.6 inches long. So no, the TV is 3.6 inches too long. And that I did by 33.6 minus 30. Number 4, what length of ladder will be needed to reach a height of 7 feet along a wall when the base of the ladder is 4 feet from the wall? So we're trying to find how tall this ladder has to be. That's C. So a squared plus b squared equals c squared. 4 squared plus 7 squared equals c squared. 16 plus 49 equals c squared. That's 65. And we take the square root of both sides. This one's a little simpler. And if I had to guess what that is, I would say it's like 8.1, but we'll double check. 8.1 feet. So my ladder would have to be at least 8.1 feet to reach that spot. If you have any questions, bring to class. I'm sure number 3 is a little confusing. We'll work through it.